Today on Capechi's Corner, we're going to look at solving absolute value equations. Now, an absolute value of a number is its distance from 0 on a number line. So let's just refresh that. If I have 0 here, and I have 3 here, and negative 3 here, the absolute value of 3 is 3, because 3 is 3 units from 0 on the number line. The same thing with negative 3. Even though I'm coming from another direction, negative 3 has an absolute value also of 3 because it is 3 units from 0 on the number line. Now, if we're looking at this example problem, it says evaluate. Remember, evaluate means to find the value. So I have my n is equal to negative 7.5 substituted in. So I have 8.4 minus. And then I have an absolute value. So I have 2 times negative 7.5 plus 5 gives me an absolute value of negative 10. So I have 8.4 minus the absolute value of negative 10 is 10. So when I simplify that, I get negative 1.6. Now, the next type of problems we're going to look at, when we see the word solve, remember we've talked about we wanted to say x is equal to a certain value. So remember up here, we had the absolute value of 3 gave us 3, and the absolute value of negative 3 gave us 3. So we're going to have 2 options. So once we are able to isolate our absolute value, that absolute value of x is by itself on one side of the equation, then we're going to split it. So x is equal to positive 6 and x is equal to negative 6. So both of these answers will work with absolute value. Unless you have 0, you're always going to have 2 options. Okay, let's look at number 2, a little bit more advanced. And again, here's my wall. My x plus 10 in my absolute value symbol is already isolated. So I can just split that right away. So I have x plus 10 is equal to positive 25 and x plus 10 is equal to negative 25. So when you split it, the first time you write the equation, you're going to just write it exactly as is with the absolute value symbol. The second time you write it here, again, no absolute value symbol, but we're going to change that positive to a negative, and then we're going to solve. So this gives me x is equal to positive 15. And then I have x is equal to negative 35. Okay, so if we were to substitute that back in to my original equation, we're going to get a true statement. Okay, let's look at number 3. Now, I don't have my absolute value symbol. I don't have that isolated yet. So this is negative 3 times that absolute value symbol. So I'm going to use the opposite operation, divide both sides by negative 3. And I have the absolute value of r plus 4 is equal to positive 7. Now that it is isolated, now I can split it. So I have r plus 4 is equal to positive 7 and r plus 4 is equal to negative 7. What a lot of students forget to do is they forget to give 2 options. They just do 1. So I have r is equal to 3 and r is equal to negative 11. So they're my 2 options. Now again, if I substitute that back in here, I would get a true statement. So in parentheses, it would be 3 plus 4, which is 7. Absolute value of 7 is 7 times negative 3 would give you negative 21. Same thing here. R is equal to negative 11. So I substitute that back in, and my R would be negative 11 plus 4, which is negative 7. Absolute value of negative 7 is 7 times negative 3 gives me negative 21. So checking it's always a good idea. Now, number 4 is slightly different. So I have it equal to 0. Now 0 is a neutral number. So there is no splitting involved here. So I just have x minus 20 is equal to 0. So x is equal to 20. So because 0 is neutral, I don't have a plus or minus. So that's the only instance in which I'm just going to get one answer. Okay, let's look at our next examples. Now, here's the thing with number 5 is a little bit different because we have our absolute value symbol set equal to a negative number. Now, think about when we went back, when we started, we said absolute value is a distance from 0 on the number line. That distance always has to be positive. So it doesn't matter what number I put in here, I cannot get a negative answer, right? Absolute value can't be negative. So there is no real solution to that. Nothing will work. Sometimes you also will see this symbol. That means it's an empty set, meaning there's nothing that works. So either way is okay. Okay, let's take a look at number 6. So again, in number 6, again, if I look at it, here's my wall. My equal sign is my wall. I don't have my absolute value isolated yet. So I'm going to bring the 8 to the other side. I need to isolate first. So I have 3x minus 2 is equal to negative 7. Now, if you notice, just like we did over here, once I isolated it, I have a negative number, which I can't have. So again, this is going to be no solution, an empty set. I can't make that work. Okay, moving on, let's take a look at number 7. So this one's a little bit different. So you probably did not see this type in Algebra 1. So I have the absolute value of x plus 10 is equal to 4x minus 8. Now, the interesting thing about that is I have that variable. So how I solve this is this number, again, I have to split it like I did. So it's going to look a little bit different. So I have x plus 10 is equal to 4x minus 8. That's going to be kind of something we've been used to. Here's where things get a little different. Okay, so I have x plus 10 is equal to, and I have to go negative 4x minus 8. Remember we had done a negative in the other examples? So we're going to have to distribute that negative through. So over here, when I solve, I'm going to bring that x to the other side and get 3x. Bring that 8, I get 3x is equal to 18. So x is equal to 6. Now, when I do this other side, I have to distribute that negative through. So I have x plus 10 is equal to negative 4x plus 8. I'm going to bring my negative 4x to their side, and I have 5x is equal to, and that gives me negative 2. X is equal to negative 2 over 5. Now, what I've said so far is we have to check our answers. And I didn't check every single problem just because of time on this video, but it is a good idea to check. So let's check this one. So first we'll start with 6. So when I substitute that back in, I have 6 plus 10, absolute value of 6 plus 10 is equal to 4 times 6 minus 8. Absolute value of 6 plus 10 gives me absolute value of 16. Over here I have 24 minus 8. So I have 16 equals 16. That gives me a true statement, so I'm okay. X equals 6 is an answer. Now, when we look at the second option, we have negative 2 over 5. So I have negative 2 over 5 plus 10 and an absolute value symbol is equal to 4 times negative 2 over 5 plus 8. When I simplify that, I have the absolute value of positive negative 3 fifths is equal to, and when I use my calculator, I get negative 9 over 3 fifths. Now, the absolute value of 9 3 fifths is going to be positive. So this answer is not going to work. We call that an extraneous solution. And you have seen extraneous solutions in Algebra 1. So what happens is that answer is not okay. The only answer for this problem is x is equal to 6. When an extraneous solution is exactly what just happened. When we did our computation, we did our math up top, it worked. But when I went to go to check it and I checked it back into the original problem, it does not work. So on a number line, the only answer you would show is x is equal to 6. Okay, let's look at our last problem for today. This is a word problem. This is kind of working backwards. It says a standard adult tennis racket has a 100 square inch head plus or minus 20 square inches. Write and solve an absolute value equation to determine the least and greatest possible sizes for the head of an adult tennis racket. Now, this is one you could probably do in your head a little bit, but I'm going to show you both ways. So let's just make sense of it. With word problems, I just like to make sense of it. So I included a number line that you can use here. Now, the thing with the number line, I always tell my students, when I was a kid, I hated in math class anytime I used a number line. But now that I'm teaching, I realize that when you're teaching math, that number line really does give you a great visual. So it says a standard adult tennis racket has a 100 square inch head. So I'm just going to make that 100. Plus or minus 20 square inches. It means I can go 20 inches over or I can go 20 inches and less. So if I make this 100, I can make this 120. That's 20 in that direction. And the same thing, I go the other direction, I get 80. Okay, so both are 20 inches from 0. Okay, so we can go somewhere in between there. So the answer is actually 80 square inches. Again, it says write and solve an absolute value, which we're going to do. Least and greatest possible sizes. So that's the least. The least could be 80 square inches, and 120 is square inches. That's the greatest. Okay, so anywhere between 80 and 120, we're good, and we've kind of followed the rules. Now, let's show an algebraic way we can do this. So the formula we're going to use, we have x minus c, and I'll talk about what that means, is equal to r. Okay, so r is the range. So in this case, our range was we could go 20 to either side. The c here is the central value. Like, what did you start with? Central value. That's what the C stands for. So you may need this formula on some of your homework problems. So when I set this up, I have x minus 100, right? The central value was 100. That's what it could go around, is equal to 20. And then I split it. X minus 100 is equal to 20. X minus 100 is equal to negative 20. And when you solve these, you get x is equal to 120 and x is equal to 80. So it